Hey, what's up guys? It's Roosevelt Williams with TinkerPro, and in this video I want to share with you a project I completed recently. Once upon a time, my granddad ordered a monitor for his PC. It was a 16-inch high, 25-inch long, 2016 Dell Ultra Sharp monitor. When this delivery came in the mail, to his surprise, he received not one, but two Dell Ultra Sharp monitors. And with no use for the second monitor, he gave it to me as a Christmas gift, and I was very grateful to receive it. This was back in 2016, and I still enjoy using my Ultra Sharp monitor till this day. Although by now, I'm sure the models of today are much nicer and sharper. Recently, my granddad upgraded his monitor to a more up-to-date one, and he gave me his old Ultra Sharp, which in my opinion still look pretty good after all these years. So now I have two identical Dell Ultra Sharp monitors, and the timing couldn't have been better, because just days before receiving my second monitor, I made some upgrades of my own. I retired my Acer Predator gaming laptop for an iBuyPower gaming PC, but I still have some use for my laptop, as you can see. Along with the purchase of my new PC, I also bought an AMSA RGB gaming mousepad, which played a major role for the inspiration of my recent project, and here's why. The mousepad is over 15 inches wide and 35 inches long, so it covered a great portion of my work desk, which is 24 inches wide and 48 inches long. I positioned the mousepad to be at the center of the desk and flush with the side closest to me while working. And I loved how it looked until I noticed something that bothered me tremendously. There was no way I could position the Dell monitors on the desk without the base of the monitors overlapping the mousepad. And I couldn't place the monitors on top of the mousepad because then there wouldn't be any mousepad left over for me to enjoy. Now, I know some of y'all are wondering, where's the issue here? Well, you see, the way my OCD is set up, I need everything to fit on the desk with no overlapping. Anything in between is unacceptable. I was so unhappy with the overlapping that I even considered returning the mousepad for a smaller one. But then the inspiration sparked. What if I designed a mount for the monitors that would position them at a comfortable level for me while working and free up space on my work desk for the mousepad? Thanks to the successful completion of the Lupal monitor mount, another mounting project I completed recently, half the design work was already done. It seemed like a great idea, but there were a couple things I was unsure about with the original design. The clamp of the original design was for a desk that was about 3/4 of an inch thick, and that thickness was consistent throughout its entire surface. Whereas the table I'm using now as a desk has a 1-inch thick surface that's recessed 1.5 inches deep, with a 2-inch thick rim circumferencing the entire underside of the table. Not to mention the hardware for the legs of the table, which made the inward thickness approximately 4 inches thick along the lengthier sides of the table. This meant that the clamp design would surely have to be reevaluated given these new parameters. The Lupal monitor mount was designed for the Lupal monitor, which is significantly smaller and lighter than the Dell Ultra Sharp monitor. There was no way the original design will hold the weight of the Dell monitor and provide the same mobility as with the Lupal monitor. Plus, attaching the monitor to the mount will have to be designed in a completely different way, given the huge difference in weight and size of the Lupal monitor in comparison to the Dell monitor. Not to mention, if my design were to fail, I ran the risk of losing a monitor. I was pessimistic about the idea at first, but then I thought, with great risk comes great reward, right? Worst case scenario, if my design was to fail and my monitor was to break, then I had a reason to upgrade my monitor just like my granddad did. That was enough motivation for me to get started on the new design. So I began taking measurements of my work desk. While measuring my work desk, I evaluated the design in my mind. I gazed out the window for a moment just thinking about how I was going to redesign the clamp to attach to the work desk. It would be so much easier and faster if I could stick with the original clamp design and develop a new way to attach the Dell monitor. Instead of killing time contemplating, I jumped right into my design to make my thoughts a reality. First, I duplicated the Lupal mount project and deleted all the components that served no purpose in the new design. Unfortunately, deleting the unnecessary components wasn't a simple task due to cross-references in designs of the mating components. My CAD designers know what I'm talking about. After a bit of back and forth in the design tree, I removed the cross-references and I was left with the clamp, the lower shaft, and the shoulder. These were all the components I needed to start the new design. I began making some adjustments to the clamp for the new design, making the length of the jaw shorter to make for a more compact and stable clamp design. But then I paused for a moment. I was still unsure about how I would adjust the design to adapt to the thicker work desk. In all honesty, I didn't want to redesign the clamp. I was looking forward to using the existing design and just working around the other components. But with my current work desk being completely different from the desk the clamp was originally designed for, I was left with no other option. I began brainstorming ideas, so much that I started to get hot. So I decided to crack open the window, and suddenly, bam! I was hit with an idea so good, I wouldn't be doing it justice if I didn't over-exaggerate. So right in front of my work desk is a window, because when I'm not staring off into the distance for inspiration, I'm usually staring out the window. Only this time, the window itself turned out to be my inspiration. You see, while opening the window, I noticed how far the window stool protrudes outward towards my work desk. Yes, that's right, the stool of the window sill. That's this part right here. How did I know that? Well, they don't call me the Tinker Pro for no reason. Ha ha! I Googled it. Anyway, I took some measurements of the stool, and it was about 3/4 inches thick, just like my old work desk. And it protruded outward towards my new work desk about 1.5 inches, which meant these dimensions were just right for the original clamp design. I was skeptical at first. I wasn't sure if the stool would be sturdy enough to hold the weight of 2 Dell monitors, so I decided to test it out. Using my body weight, I applied a little pressure to the stool and it was stiff as a board. I was sure my idea would work now. Now this idea was golden for 3 reasons. 1 being that the window is directly in front of my work desk. 2, by mounting the monitors to the window sill, I'd be able to use 100% of the surface of my work desk. And 3, I can mount the monitors without having to redesign the clamp. It was a win-win. Now before I could attach the monitor to my design, I needed to understand how the monitor attached to the stand that came with it. To detach the monitor from its stand, there's a push button on the back side of the monitor just underneath where the monitor connects to the stand. Once I push this button, I pull the monitor forward from the rear and lift upward, successfully detaching the monitor nice and easy. I flipped the monitor around and examined its backside to familiarize myself with its design features and to understand how those features connected with the monitor stand. There's a 4 7/8 by 4 7/8 square cutout on the rear side of the monitor where the stand fits and connects to the monitor like the last piece of a puzzle. There are 2 openings on the upper side of the square cutout where 2 tabs from the monitor stand will be inserted. The 2 tabs on the monitor stand protrude upward from the mounting face. It appeared to me that most of the weight of the monitor is held by these 2 tabs alone. Otherwise, without them, the monitor would just fall forward. The push button on the back side of the monitor is spring-loaded and connected to 2 triangular tabs that go inward when the button is pushed and outward when the button is released. On the bottom of the mounting face were 2 more tabs. These tabs were significantly different from the tabs at the top. They bent outward slightly and then downward. Intuitively, I knew that once the spring-loaded push button was released, the triangular tabs would insert themselves between the bends of the lower tabs, firmly securing the monitor to the stand. It made perfect sense for these components to be made of metal, but would 3D printed plastic components work the same? I was uncertain, but I continued forward. After I was sure I fully understood how the monitor connected to the stand, I began reverse engineering the design to work with my own. I took precise measurements of the mounting plate on my monitor stand and I replicated it in my 3D model. I started out with a 5 by 4 inch rectangle. I extruded it over 1/4 inch thick, and then I added 2 tabs at the top of the rectangle. These tabs were extremely concerning because, as I mentioned earlier, they would hold a majority of the monitor's weight to prevent it from falling forward. The dimensions of the tabs on the monitor stand were very thin. They were a little under 1/2 inch wide, they protruded upward a little under 1/2 inch, and they were less than 1/10 in thickness, so I knew the dimensions would have to be larger to work for my design. I understood how these tabs worked using the components intended for the design of the monitor stand, and my conscience was telling me I would not get the same results with my 3D printed components, but I continued forward. Next, I replicated the lower tabs into my model. These tabs were slightly more tricky because they had bends that created a small opening for the triangular inserts on the back of the monitor. I had to get the spacing and opening just right to ensure it works just like the original. After that, I designed how the mounting plate would mate with its connecting component, which in my original design was called the shoulder. Like most of this project, I didn't want to reinvent the wheel. I wanted to keep as much of the original design as possible. So instead of redesigning the entire shoulder, I just added to it. If you saw my last project, then you probably remember the shoulder component. And if you paid attention, then you probably remember that the shoulder component has a surface that protrudes outward 1 3/4 inches. And if you remember nothing at all, then at the very least, thanks for watching, I guess. I made slight changes to the design of the shoulder, making the diameter of the protruded surface the same as the diameter of the portion that connects to the shaft. Then I extrude a 3-inch tall cylinder from the protruded surface of the shoulder to start designing how the mounting plate and shoulder will connect. Using the same diameter as the cylinder, I sketched a circle 1 3/4 inches from the center point of the mounting plate, with 2 lines tangent to the circle, one from the top edge of the mounting plate and one from the bottom edge of the mounting plate, to create a 1-inch thick triangular insert on the back of the mounting plate. Now, going back to the cylinder, which I now call the neck of the shoulder, I cut out a 1-inch thick slot that was 1 3/4 inches deep from the top of the neck. I cut a 1/4 inch hole through both sides of the neck slot. I also cut the same hole through the triangular insert of the mounting plate. At this point, you can kind of see where I'm going with the mating connection between these two components. I played around with the size of the insert and slot to make sure I have the proper thickness for a fastener to be added later during installation. Now that I had a good idea for how I wanted these components to connect, I began editing the design of the neck to support the mounting plate in its current position, which was crucial to me because the mounting plate was positioned in a way that the monitor would be perfectly perpendicular to my work desk. In order to keep the mounting plate in its current position, I started making adjustments to the neck of the shoulder. I created a slope in the neck that matched the angle of the triangular insert of the mounting plate. This way, the weight of the monitor will rest on the slope of the neck and thus be further supported by the connection of the shoulder to the shaft. Hello? Are you guys following? Are you still there? Are you awake? I hope so. I know this is like my 5th year's mounting project, and I may as well be the mounter pro at this point. But things will get more interesting in time. For now, just keep watching. Or don't. I don't care. But remember this, real recognize real. And the moment you stop watching, you start looking real unfamiliar. Anyway, I added 1 inch to the length of the neck, making it 4 inches long instead of 3. And I made a few slight adjustments to its design to make for a cleaner finish. Moving forward, I started making adjustments to the neck and shoulder connection. I realized I made the neck and shoulder 2 separate components, so I combined them and removed the through hole and counterbore from the original shoulder design. After that, I practically recreated everything you already seen me create, so I won't make you watch me do it again. Once the shoulder and neck components were combined, I added a variable chamfer to the back side of the mounting plate to make the overall design more structurally sound and give it a smoother looking finish. Although the stool of the window sill was 3/4 of an inch thick, just like my old work desk, there were still modifications that would have to be made to the clamp to make it a perfect fit. The underside of the stool protrudes from the window 1 5/8 inches. So I adjusted the support angle of the fixed jaw to leave approximately 2 inches of space in the clamp zone, and I made the support angle slightly thinner than before to make the design less beefy. I made modifications to the movable jaw as well, increasing its surface area and adding an additional rib to its underside for improved support when clamped. And just like in the original design, I added 1/32 fillets to every edge of each completed component. It was now time to print, and there was one component I couldn't get off my mind, and that component was the mounting plate. I was still pretty unsure about those tabs, and I didn't have a lot of faith that they would work, but I'm committed to my craft. And once I start a project, I have to finish. So I started Prusa Slicer, exported the G-code, and fired up my 3D printer. Here was the result. The mounting plate printed just fine. It was strong and very dense, but there was one slight issue. The plate was oversized, and the position of the upper tabs were completely off. It appeared at some point in my process I fell asleep at my desk because there was no other way to explain these silly mistakes. I went back into my design to fix the issues. I decided to add a little more detail to the mounting plate, and I made the tabs thicker with hopes that I'd get it right the second time around. Once again, the mounting plate printed just fine, and this time it fit to the monitor like a glove. The upper tabs inserted with ease, and the lower tabs worked exactly how the design intended. The day was getting brighter, but I wasn't out of the darkness just yet. I still had to test it out. To test the design, I used a small hand towel to lift the monitor by the mounting plate. The hand towel made it easier for me to grip the smooth surface of the mounting plate during testing. I learned the hard way that the smooth surface of the print combined with the weight of the monitor did not play well with my oily fingers. I lifted the monitor up and down a little to see if it will hold, and it did. Surprisingly, the design was working. It was off to a good start, and I was happy to see that. But still, testing had only just begun. For the second test, I held the monitor by the mounting plate again, but this time in a more practical position. I tilted it up and down and everything was going as planned until snap. The monitor fell flat on its screen. Thankfully, there was a nice soft pillow below to cushion the fall. This was premeditated, of course. I mean, I have faith in my designs, but I'm not that crazy. Just when it seemed the sun was shining bright, it turned out I was only in the eye of the storm. My design failed and I was in darkness yet again. My initial idea did not work as I imagined. But as I've said in the past, where there's a will, there's a way. I sat and brainstormed for several days and several nights. This was supposed to be a quick and simple project, but it was becoming more complicated. The main issue were the tabs. They were just too weak to hold the weight of the monitor over an extended period of time without eventually failing. I had very little room to get creative with the design of the tabs without introducing another material or object stronger than 3D printed plastic to the design. Plus, like I said, this was supposed to be a quick and easy project. I really just wanted to complete my PC setup with dual ultra sharp monitors. I began examining the back of the monitor more thoroughly with hopes of finding a stable point where the monitor can rest on the mounting plate in a more secure fashion. That's when I noticed these 4 screws conveniently placed in 4 locations, making a perfect square inside the rear opening of the monitor. Suddenly, bam, another great idea came to mind, but this one had no need for exaggeration. I'll explain why in a bit. What if I utilized the conveniently placed screw holes to fasten the mounting plate to the back of the monitor? I knew right away this idea would surely work, but I wanted to know what was the purpose of those screw holes in the first place. When I removed the screws from the monitor, there wasn't any indication that they served any real purpose. I was quite confused, so I Googled it, and it turned out these were monitor mounting screws used for mounting the monitor to a stand, visa mount, or wall mount. Boy, did I feel dumb. I wasted time and effort trying to resolve an issue with the solution right in front of me the entire time. You know, they say mess around and find out. Well, I messed around and I found out. After I stopped feeling dumb for myself, I made changes to my design to implement this new great idea I discovered. I started making some slight adjustments to the lower tabs. Though they worked well, I felt like there could be more detail added to better replicate the monitor stand mounting plate. After that, I measured the position of one of the mounting screw locations. Since the locations made a perfect square, I only needed one of them. I created a reference sketch with the dimensions of the opening for the monitor stand. The hole positions were approximately 7/16 from each side of the opening, and I made the holes 0.20 inch in diameter. Once I finished the sketch, I cut the holes through and adjusted the thickness of the upper tabs to be flush with the edits I made in the beginning. I offset a plane from the front face of the mounting plate to create 0.33 inch diameter counterbore holes on the rear side of the mounting plate. The counterbores were for washers that will be added during installation. I added a small chamfer to the lower tabs for extra support. and I made some slight adjustments to the upper tabs as well. Unsatisfied with my design, I decided to go back and remove the chamfer and counterbore holes I created prior. Instead of 0.33 inch diameter counterbores, I went with 1/2 inch diameter counterbores at 0.06 inches deep. I added the large chamfer again, this time a 3/4 inch chamfer instead of one that goes around the entire surface of the mounting plate. To finally complete the design, I added 1/32 inch fillets around the entire part. Inspired by the changes I made to the mounting plate, I decided to make some changes to other components of my design. To improve the clamping strength, I increased the diameter of the adjustable screw. I kept the old adjustable screw in the model to use as a reference for the new one. I adjusted the diameter of the lower jaw and handle following the new diameter of the adjustable screw. I also changed the text size on the outside face of the fixed jaw. I created a reference sketch of the monitor's overall dimensions to determine the height of the monitor relative to the fixed jaw. By reducing the height of the shaft by almost 1.5 inches, the bottom of the monitor will be almost 1/4 inch from the top of the fixed jaw. To give a better representation of what I was looking to achieve, I created an assembly file with both mounts and a small detail of the window stool. Again, it was time to print, but before printing, I made a trip to Home Depot to find out what type of mounting screws were used on the monitor. Using Home Depot's helpful thread finder, I discovered the screws were M4 0.7 millimeter screws, and I bought 4 packs of 2 along with some M4 0.7 millimeter washers to match. Again, thanks to the successful completion of the Lupal monitor mount, I already had all the other screws, washers, and nuts I needed for the design. I printed all the components of my design for a total print time of 104 hours and 30 minutes. All the prints came out perfect as expected, and I began the assembly process, which was very similar to the assembly of my last project. I'll touch more on the assembly process later in this video. After assembling the components, I attempted to install my design to the window stool. During the installation attempt, I realized I put so much focus on the design of the mounting plate that I completely disregarded the other components. The handle, lower frame, and movable jaw components were all too large for me to even get the mount close enough to the window without the components colliding with the wall and apron of the window. Again, this issue easily could have been avoided had I not fallen asleep during my design process. But I wasn't going to cry over spilled milk. Remember, this was supposed to be a quick and easy project. I didn't want to go through the process of redesigning the components. So to make it work, I took a shortcut and I made shortcuts, literally. I got out my trusty Dremel 8220 and I cut each component, removing just enough material for me to install the clamp to the window stool. Now, I knew this was a tacky solution and there was no way I was going to consider this a completed project, but it was temporary. I was so anxious about testing the design, I just wanted to see if it would work so I could be done with the project. To my surprise, it actually worked out. The clamp gripped the window stool tightly with no signs of failure, even after applying the weight of the monitor. The monitor leaned forward slightly, so it wasn't perfectly perpendicular to my work desk, but you wouldn't notice it looking directly at the monitor screen, so I didn't worry about that too much. Thanks to the design of the shoulder component, I was also able to rotate the monitor left and right, which was a neat bonus of the design I hadn't considered beforehand. Finally, everything worked out. The design was properly installed and operational, but I didn't print the second mount right away because there was still one test left. The test of time. I left the monitor mounted to the window stool for several months. There were no issues, no signs of failure. After all that time passed, I can finally begin printing the components for the second monitor mount. The project was a success, or so I thought. You see, just as I was waiting for the last component of the second mount to print, I noticed some things about the first mount that just weren't sitting right with me. The mount was still firmly clamped to the window stool as intended, but there were some imperfections in the design that began to show, and I couldn't just ignore them regardless of how long the design held out. After months of using the monitor and mount, I noticed that when I lift the monitor screen, the entire base clamp will also lift upward. This was not a good sign for the longevity of the clamp, because I felt over time this may get worse. I noticed that the front of the fixed jaw was slightly lifted upward away from the upper surface of the window stool. This was not a good sign either, because ideally the entire clamping surface of the fixed jaw should have been fully engaged with the upper surface of the window stool. The mount technically worked, it performed as intended, and this was supposed to be a quick project. But despite all that, I couldn't get over the flaws that I discovered. So I went back to the drawing board because my OCD would not allow me to simply accept the work that had been done. It was tacky and it didn't represent TinkerPro in the best way. This simple project that was supposed to be quick and easy was once again becoming ever so complicated. Before going back into my design, I took some time out to analyze the cause and effect of the imperfections I discovered. Right off the bat, I understood why the fixed jaw wasn't fully engaged with the window stool. The window stool protrudes from the window 1 5/8 from its underside, while the upper side of the window stool is recessed into the window 3 5/8. The original clamp was not only designed to clamp to a surface with a consistent thickness, but it was also designed to clamp at the same depth above and below. Also, both jaws have the same center point. So to achieve the most optimal clamping strength, both jaws would need to be fully engaged with the clamping surface. However, with the window stool, the upper and lower surfaces did not have the same depth. One was 1 5/8 at max, and the other was 3 5/8. So with the application of the design to the window stool, this meant the maximum depth achievable for the original design was limited to 1 5/8 on the movable jaw and 2 inches on the fixed jaw. This created an imbalance because the rear face of the fixed jaw stuck out from the window sill too far, to the point where the weight of the monitor eventually caused the entire clamp to lean forward more drastically than it did when I first installed the mount. Thanks to the ball joint connection between the movable jaw and adjustable screw, the clamp was still tightly clamped to the window stool, supporting the monitor. However, it was only holding on 1 5/8 of the underside of the stool, which was not deep enough to keep the fixed jaw fully engaged with the upper side of the stool. And that resulted in the design appearing to be too top heavy. To top it all off, with little force, I was able to move the clamp left and right, which was something I wasn't able to do in the beginning. This meant the design may have gotten weaker over time, potentially due to these imperfections. Despite all these ugly issues, it seemed the design would have worked, but I'm uncertain for how long. After analyzing the flaws of the first design attempt, I started making changes to my model to start my second and hopefully final design for this project. First things first, I incorporated the cuts I made from the physical parts to my actual design, starting with the lower jaw. I got an approximate measurement of how much material I removed from the front end of the fixed jaw, and I replicated the change in my design. After removing the material, I made adjustments to the overall design of the part to complement the change, integrating it seamlessly into the design. I did the same thing with the handle, first removing the fillets from the original design, then cutting away material to mimic the physical cuts I made to the part. I reduced the handle to form a knob that was 1.25 inches wide and 2.25 inches long, just slightly larger than the diameter of the handle collar. I added fillets to the knob to give it smoother edges to make it easier on my hands when tightening the clamp. I cut a 1/4 inch by 1/4 inch slot right through the bottom of the knob. This slot will provide leverage when tightening the clamp. You'll see how later. Working backwards, I saved my design as version 2 for a clean start, and I began removing design features from the rest of the components. The redesign began with the fixed jaw. I pushed back the side angles to create more surface area for the center point of the fixed jaw for better engagement with the window stool. In the original design, the fixed jaw covered about 2 inches of the upper surface of the window stool, 3/8 over the 1 5/8 of the movable jaw on the underside of the window stool. Like I mentioned earlier, this flaw played a role in the imbalance of the original design. In order to fully engage the fixed jaw with the window stool, I needed the clamping area of the fixed jaw to cover more than 2 inches of the window stool. Pushing back the side angles of the fixed jaw not only brought the clamping area deeper into the window stool, but it brought the outer face of the fixed jaw closer to the window to better stabilize the position of the clamp on the window stool, correcting the imbalance seen in the original design. I cut away material from the rim of the fixed jaw's collar to slim down its design a bit. I made the same adjustment to the lower jaw to make the cut look uniform between both components. Next, I created a small section of the window stool and frame to add to my model. You can see how when the fixed jaw is fully engaged with the upper surface of the window stool, the lower jaw and handle crash into the lower portion of the window frame. In order to correct this, I needed to shift the center point of the lower jaw backwards until the lower jaw and handle cleared the apron of the window frame. The fact that both the fixed jaw and lower jaw were designed with the same center point was also another reason for the imbalance in the first design. Now that I could fully see the problematic areas of the design, I began making more adjustments to the components. I needed to push the center point of the lower jaw back. However, due to cross references between its design and the design of other components, doing so became very complicated. So I decided to recreate the lower jaw in a separate file with the desired changes already incorporated. Recreating the lower jaw was pretty straightforward, although it took some back and forth. Once I finished it, I inserted it into the new design. After recreating the lower jaw, I started redesigning the movable jaw. I replaced the original circular shape with a more rectangular shape that better matched the shape of the underside of the window stool. This was a design feature that should have been accounted for in the beginning, but again, this was supposed to be a quick and easy project, so I didn't think it was necessary to change its design. I recut material from the side angles of the fixed jaw to improve the aesthetics of the design. And then I moved upward to make adjustments to the shoulder and neck. The shoulder protrudes outward from the center of the shaft. This protrusion, also known as the neck, contributed to the top-heavy outcome of the first prototype. So I decided to push the neck more towards the center of the shaft. This change not only prevented the top-heavy look in the design, but it also provided more support for the component by bringing it closer to the center of the shaft. After the shoulder and neck were complete, I made some finishing changes to the fixed jaw. I added 1/32 and 1/4 inch fillets to round off the edges, and I included 3 indented areas for bumper pads to be placed later during installation. I also made some slight adjustments to the handle design, removing edges that I felt were unnecessary and increasing the slot on the bottom from 1/4 inch to 0.33 inch. The end result was much more satisfying than before. I went through the same finishing process with the movable jaw, adding fillets to the edges, and I included 2 indents for bumper pads to be placed later. Lastly, I added fillets to the shoulder and neck, finalizing those components as well. As usual, I had second thoughts about the handle design, and I decided to make some last-minute adjustments that I felt were an improvement to what I had done prior. I also decided to 86 the lock pin idea for this new version of the design, because I didn't actually use it in the first prototype, and the clamp held up pretty well for quite some time. Last but not least, I signed off on my work by writing the Tinker Pro headquarters on the back face of the fixed jaw, thus completing the second version clamp design. Now that the design was finally complete, I was ready to begin the 3D printing process for what I was hoping was the last time. With my fingers crossed, I gathered the components for printing, estimating a total print time of 90 hours and 35 minutes. 3 days later, I gathered the finished parts, assembled them, and installed my creation onto the window stool. Here was the result. The second version design was a complete success. The clamp was fully engaged with the window stool firmly from both the fixed and movable jaw. I was sure I got it right this time around because with the second version design, the monitor was perfectly perpendicular with my work desk, whereas in the first design, there was a slight lean forward. And when you compare both designs side by side, there is a clear difference between them. After 6 months and a ton of migraines, this quick and easy project was now behind me. Thank the heavens. Of course, before I end this video, here's a quick and easy rundown on installation of the monitor mount. And this time I promise it will be quick and easy. Just like the Lupal monitor mount, installation begins with the assembly of the sub-assemblies. And for this design, there are 2 of them. The base subassembly and the monitor subassembly. Let's get into it. The base subassembly consists of 6 components: the fixed jaw, the lower frame, the adjustable screw, the handle for the adjustable screw, the movable jaw, and the lower shaft. These components are assembled using 3 1.5 inch long 1/4-20 round head screws, 3 1.25 inch long 1/4-20 round head screws, 1 2-inch long 8/32 round head screw, 7 1/4-20 nuts, 1 8/32 nut, and 3 1/4-20 washers. First, I connect the lower shaft component to the fixed jaw by aligning the 3 holes at the top of the fixed jaw with the 3 holes at the bottom of the lower shaft. The lower shaft has 3 slots near the bottom where the first 3 1/4-20 nuts are inserted to mate with the first 3 1/4-20 round head screws. Once the holes of the shaft and fixed jaw are aligned, I insert the 3 1/4-20 screws and fasten them in with a standard Phillips screwdriver. There are 3 slots with 1/4 inch diameter through holes on the outside face of the fixed jaw for 3 more 1/4-20 nuts. I place the nuts in these slots and I set the base off to the side. I grab the lower frame and I place 3 washers in the 3 counterbore holes on the front face of the lower frame. The counterbore holes also have 1/4 inch diameter through holes. After placing the washers, I align the 3 lower frame through holes with the 3 through holes of the inside face of the fixed jaw. I then insert the remaining 1/4-20 round head screws and I fasten them in place with the screwdriver. After that, I sit the base to the side again to assemble the handle and adjustable screw. The handle has a single slot for the 1 8/32 nut and a 1/4 inch diameter through hole that goes through the neck of the handle. Once the nut is in place, I insert the adjustable screw to the handle and connect both components using the screwdriver to fasten the 2-inch long 8/32 round head screw. The 2-inch long screw goes through both the handle and adjustable screw, so when tightened, these components are firmly connected. Now, I want to insert the adjustable screw to the lower frame. But before doing so, I add a little Vaseline to lubricate the adjustable screw, making it easier to tighten the clamp. I carefully insert the adjustable screw and I turn it into the lower frame just enough to add the movable jaw. The movable jaw has a press fit connection thanks to the ball joint of the adjustable screw, so it snaps on nice and easy. You can ignore the remaining 1/4-20 nuts. They're only here for production purposes. The actual 1/4-20 nuts have been pre-inserted into the lower shaft as seen earlier in the assembly process. Last but not least, I add the self-adhesive Gorilla Grit bumper pads to the fixed jaw and movable jaw to put the icing on the cake. The base subassembly is now complete. The monitor subassembly consists of 3 components: the shoulder, the neck component, the mounting bracket, and the monitor itself. These components are assembled using 4 M4.7mm by 18mm screws, 4 M4.7mm washers, 1 1/2 inch long 1/4-20 round head screw, and 1 1/4-20 nut. First, I attach the monitor bracket to the back side of the monitor, placing the bracket in by the upper tabs first, then snapping it in place by pressing in the lower tabs. Next, I place the 4 M4.7mm washers into each recessed pocket of the mounting bracket, and I fasten the bracket to the monitor using the 4 M4.7mm by 18mm screws and the Phillips screwdriver. Lastly, I connect the shoulder and neck component with the monitor bracket by lining up the 1/4 inch diameter holes of the slot on the shoulder and neck with the 1/4 inch diameter holes on the triangular side of the mounting bracket, and I fasten both components together using the 1.5 inch long 1/4-20 round head screw and the 1/4-20 nut. Now that the sub-assemblies are complete, we can begin installation. To install the monitor mount, I first place the fixed jaw flat on the upper surface of the window stool. Then I begin turning the handle until the movable jaw is pressing against the underside of the window stool. Once the movable jaw is touching the underside of the window stool, it will become very difficult to fully tighten the clamp with my bare hands. So I use my screwdriver to give me more leverage and create more torque by placing the screwdriver through the slot on the bottom of the handle. After the clamp is fully tightened, I connect the monitor assembly by sliding the shoulder and neck onto the lower shaft. Then I fasten the monitor assembly to the clamp using the 1/2 inch long 1/4 screw. And just like that, installation is complete. Well, there you have it. A quick and easy project that wasn't very quick and overly complicated for no apparent reason. But we got the job done. And I assure you, my mental health was in no way damaged throughout the completion of this project. I hope you guys enjoyed this video. Be sure to like, share, subscribe, and be on the lookout for more content to come. Thanks for watching.